Every year this will be in news, and the most important part is that questions are also asked in the examination from this particular area. So from with that respect as well, this part is very much important, right? 18th of April, it's the Albert Einstein's death anniversary, and I hope every one of you know this theory of relativity. Whenever this thing comes, every time the picturization of Albert Einstein also comes to our mind, isn't it? So this theory of relativity, one thing we have learned is the Newton's gravitation theory, right? I hope I'm not going to discuss it in a scientific manner because not everyone is from that particular background, but at least if you picturize in your mind regarding the falling of apples, by which Isaac Newton led into the mind of Isaac Newton that yes, there is a force which pulls everything towards itself, and that force we call it as gravitational force. Every one of you know, I suppose, at least this particular story, right? Yes. So the thing is that this relativity theory, it's a refinement of that Newton's theory of gravitation. Okay, Newton's theory of gravitation is having certain kinds of disadvantage, and these advantage, if you see normally, if you see in our towards ourselves in our surroundings, we will feel as if Newton's theory of gravitation is being applied everywhere. But in reality, if you go in space, somehow there are certain loopholes in the Newton's theory of gravitation, and this is why some refinement was required, and this refinement is the general theory of relativity given by Albert Einstein. Okay, it's the theory of relativity given by Albert Einstein. And under this theory of relativity, very, very important thing you need to know is that it also tells about the prediction of black holes. I hope you remember what are black holes, right? With this particular theory of relativity, you can understand regarding certain concepts of black holes. Yes, and what this theory of relativity basically talks about, it talks about a four-dimensional structure of space-time. Just look into this particular picture. It is a fabric of space-time. This particular green colored thing that you have seen, this we call it as fabric of space-time. Imagine a net, yes, a fish net or a net in which if you drop a ball, if you drop a heavier mass, automatically this mass will be acquired by the net, right? And it will create it will dig some kind of curvature, isn't it? A kind of curvature. This is something, same kind of thing happens in the universe as well. And in the universe, we call it as a fabric of space-time, in which all these celestial bodies, as they have mass, we all know that for the force of gravity, a very important factor is the mass. Higher is the mass, more will be the gravity. Do you know this fact? More is the mass, more is the gravity or the gravitational force. So similarly, if you see, this is the sun, isn't it? The sun is having higher amount of mass. Since it's having higher amount of mass, therefore this curvature in the fabric of space-time will also be more. Consider this to be our Earth. Yes, this Earth is comparatively less. It weighs less compared to the sun. So the curvature that will be created in this particular fabric of space-time will be less compared to the sun. So this is how this entire explanation of what all these things has been given by the general theory of relativity. So it basically talks about the four-dimensional space of the fabric of space-time, of how planets are revolving around the sun, how our moon is revolving around the earth, and how the planets are also revolving around the sun in the curvature in the fabric of space-time. Are you being able to understand? It's a kind of demonstration. Yes, normally if you see, it's in this particular thing, the Newtonian law of gravitation, the basic Newtonian law of gravitation, and repeat again, it has this advantage, right? Because it does not talk about the black holes, right? It does not talk about dark matter. It does not talk about dark energy. I think you all, I have taught you these terms: dark matter, dark energy, black hole. All these things are not being considered in the Newtonian mechanics, Newtonian law of gravitation. But in reality, we all know that this dark matter exists. Yes, dark matter exists, although we cannot see, but we have got different kinds of proofs. Do you remember that dark energy also exists? Black holes also exist. This is the reason for which this general theory of relativity is very much important. Now, coming to the black hole, what is black hole? We all know it's a hole with infinite amount of gravitational pull. It is having so high amount of gravity that even light cannot escape. Even, isn't it? So this is this, just look, this is how light, here is the black hole, just look, the black hole is present, and the light that was present, light is also being trapped under the black hole. So this is a kind of thing. Black hole is here, light is being trapped in the black hole. It is having infinite amount of gravitational pull. So if you imagine this to be a black hole, then this we call it as event horizon, and this point we refer it to as the point of singularity, isn't it? This is the point of singularity in which gravitational field, the gravitational force is infinite. Trust me, remember the word of infinity. When we use the word infinite, it means huge. You cannot imagine. Just because in the point of singularity here, the gravitational force is infinite. This is why anything that comes in the event horizon cannot escape back. It has to go deep inside the black